Hello guys, welcome back to Shree Radhe Studies.
I hope you all are doing great. Today we are going to study chapter 7, game playing in artificial intelligence, one of the most interesting topics in AI because it teaches us how computers think strategically while playing games like chess, tic-tac-toe, checkers and even Go. If you haven't watched the previous chapters yet, I highly recommend checking out the AI playlist on our channel first. Those chapters explain the basics that will make this topic much easier to understand. So, without wasting any time, let's begin today's chapter. Slide 1, Game playing in artificial intelligence. Let's first understand what game playing in AI actually means. Whenever humans play a game, we think before making a move. We try to predict what our opponent might do next and then choose the best strategy. Artificial intelligence works in almost the same way. Instead of making random moves, AI analyzes every possible move, predicts future outcomes, and finally selects the move that gives it the highest chance of winning. This technology is used in games such as tic-tac-toe, checkers, and Go. These games require planning, logical thinking, and decision making rather than luck. The main objective of game playing AI is simple: make the best possible move while assuming that the opponent is also playing perfectly. Slide 2, Types of AI games. Now, let's understand how AI games are classified. The first classification is based on randomness. In deterministic games, there is no element of luck. Every result depends completely on the player's decisions. Chess and tic-tac-toe are good examples. On the other hand, stochastic games include randomness, such as rolling dice or drawing cards. Games like poker and backgammon belong to this category. The second classification is based on information. In perfect information games, every player can see the complete game state. Nothing is hidden. Chess is the best example. In imperfect information games, some information remains hidden from players. Poker is a common example because you cannot see your opponent's cards. Finally, we have zero-sum games. In these games, one player's gain is exactly equal to the other player's loss. If one player wins, the other automatically loses. Most strategy games follow this model. Slide 3. Role and applications of AI in gaming. Artificial intelligence plays a very important role in modern games. It helps computers make intelligent decisions instead of following fixed instructions. AI predicts the opponent's moves, plans better strategies, and adjusts its gameplay according to the player's skill level. Have you ever noticed that game enemies become smarter as you improve? That's because AI can dynamically adjust the game's difficulty. AI is also responsible for creating realistic non-player characters, generating new levels automatically, balancing gameplay, and even providing personalized experiences for different players. Popular games such as GTA, Fortnite, and Civilization use AI extensively to make gameplay more realistic and engaging. Slide 4. Core functions of AI in gaming. Let's now look at the major functions performed by AI inside a game. The first function is controlling NPCs, also called non-player characters. These are computer-controlled characters that behave intelligently, attack strategically, defend themselves, or even help the player during gameplay. The second function is game world management. AI can automatically create maps, generate levels, adjust game difficulty, and keep the game environment dynamic. Another important feature is personalized gameplay. AI studies the player's behavior and adjusts the experience accordingly, making the game more enjoyable for beginners as well as experienced players. Overall, AI improves realism, player engagement, and significantly reduces the workload for game developers. Slide 5. The Minimax algorithm. Now we come to one of the most important algorithms in game playing AI, the Minimax algorithm. Minimax is mainly used in two-player, turn-based, zero-sum games. The algorithm assumes that both players are extremely intelligent and always make the best possible move. There are two players involved. The max player always tries to maximize the score and select the best possible move. The min player tries to reduce the max player's advantage by choosing moves that minimize the score by continuously considering both players' best decisions. The algorithm eventually finds the optimal move. This algorithm is commonly used in chess, tic-tac-toe, checkers, and Connect 4. Slide 6. Working of the Minimax algorithm. Let's understand how Minimax actually works. First, the AI creates a complete game tree containing all possible future moves. Then it evaluates every final position and assigns a score to each outcome. Next, the scores are propagated back toward the root. Whenever it is Max's turn, the algorithm chooses the highest score. Whenever it is Min's turn, it chooses the lowest score. This process continues until the algorithm reaches the root node and selects the best move. The biggest advantage of Minimax is that it guarantees the optimal decision. However, its biggest drawback is that it has to evaluate a huge number of game states, making it slow and memory intensive for large games. Slide 7. Alpha-beta pruning. To solve the limitations of Minimax, we use alpha-beta pruning. Think of it as a smarter version of Minimax. Instead of checking every possible branch of the game tree, alpha-beta pruning ignores branches that can never affect the final decision. This greatly reduces computation while still producing exactly the same answer. Because fewer nodes are evaluated, the AI becomes much faster and can search deeper game trees in the same amount of time. That is why almost every professional chess engine uses alpha-beta pruning instead of plain Minimax. Slide 8. How alpha-beta pruning works. Now let's understand the two important values used in alpha-beta pruning. The first value is alpha, represented by the symbol alpha. Alpha stores the best value that the max player can guarantee so far. Initially, it starts from negative infinity. The second value is beta. Beta stores the best value that the min player can guarantee and starts from positive infinity. During the search, if alpha becomes greater than or equal to beta, the remaining branches are immediately ignored. This is called pruning. These branches cannot improve the final answer, so evaluating them would only waste time. Slide 9. Minimax versus alpha-beta pruning. Let's compare these two algorithms. Minimax evaluates every single node of the game tree. Alpha-beta pruning skips unnecessary nodes. As a result, Minimax is slower and requires more computation and memory. Alpha-beta pruning is much faster and more efficient while still producing exactly the same optimal decision. Because of this, alpha-beta pruning is the preferred choice in modern game engines and AI systems. Slide 10. Summary. Let's quickly revise today's chapter. Game playing is one of the most important applications of artificial intelligence. AI uses game trees to analyze possible moves before making decisions. The Minimax algorithm guarantees the best move by assuming both players play perfectly. Alpha-beta pruning improves Minimax by eliminating unnecessary branches, making the algorithm much faster without changing the final result. These concepts are widely used in chess, checkers, Othello, and many modern AI-based game engines. Understanding these algorithms gives us a strong foundation for learning advanced artificial intelligence techniques. Thank you so much for watching. If you found this video helpful, don't forget to like, share, and subscribe